Hi, I'm recording this video for my GCSE electronics students. We're going to have a look at question 1 of the recent Year 10 mock exam paper. So question 1 actually was generally mostly successfully answered by students. These are the class averages, so 82% was this, the average score across the class. So question 1, we've got an IC, in other words we've got something like this. And most ICs are not too sure how well you'll be able to see this, probably not in this light, but on the left hand side, bottom left, there was a circle there, and that denotes pin 1. And also sometimes you don't have that circle, but with this little cutout things like you should be able to work out what that is pin 1. State the number of logic gates on this IC. So there are 6 gates, 1, 2, 3, 4, 5, 6. It's only worth 1 mark. State the number of inputs on each gate. Well, hopefully you can see that these are NOT gates. NOT gates have only 1 input and then 1 output. But it does say on each gate, there were a few students who actually gave me the total number of gates, or even number of pins, but it says the number of inputs on each gate. So 1 input, 1 output. Okay, so 1 input. State which pin is pin 1. It's going to be pin this one, okay, C. And the type of logic gate, it's a NOT gate, otherwise known as an inverter. Next, we need to draw the logic gate symbols for these 2 logic gates. Now, although most students actually did get this right, there was sometimes a little bit of variation from what I was really looking for in the symbol. Do be careful when you draw these. An AND gate. I say sometimes it looks like the letter D. An AND gate should have a nice flat side on the inputs, fairly rounded on the output, like that. Okay. Now it doesn't matter whether you've got, and by the way that should actually join up there, it doesn't matter whether it's 2 inputs or 3, you could even have more than that, but when they ask you something like this, just do a 2 input gate. Assuming that it's an AND or an OR, but not. A NOT gate would have just a single input. If you wanted to, you could do A, B, and Q or whatever. Doesn't matter. Okay, that's not part of the answer. Okay, so that's the logic gate for an AND. Just 1 mark. You either get it right or wrong. And then we've got a NOR gate, which is like an OR gate, but then passes through a NOT gate. But there is a symbol for that, so the input side needs to be curved. Okay, sorry, it's just off the screen there. These sides need to be curved. It needs to go to a point like that as well. That's pretty much standard way it's drawn. And then once again, you can do A, B, and Q if you want, or whatever. It doesn't matter. Oh, I nearly made a mistake there myself. Okay, a NOT OR. Okay. All right, so do make sure that you've got that circle on there, and too much talking almost left it off. All right, okay, without the circle it's an OR gate. With the circle it becomes a NOR gate. In other words, it's like an OR and then it goes through a NOT. Okay, so that thing together is that. Okay, but you don't need to draw any of that at all. Okay, NOR gate. Next bit then, truth tables. You should be able to recognize these. Let's just have a quick look through. If any of the inputs are true, the output's true, that's an OR gate. You're not actually asked to label all these, but we'll do these. If input is 0, the output's 1. If input's 1, the output's 0, that's a NOT gate. You can also see that because it's only got a single input. Do be careful though, because you know, if the input and the output were the same, that would be what we would call a buffer. I don't think they're going to do that to you in GCSE. Okay, this one, if both the inputs are true, the output is false. Otherwise, the outputs are true, or 1. Okay, this is a NAND gate. With a NAND gate, if any or all of the inputs are 0 or false, then the output is true. You can also view it another way. You can view it as it's the opposite of an AND gate. An AND gate will have a 1 when both inputs are true. That would be a 1. All those would be 0. But because it's a NAND, it's an AND and then not it. This one, only true when both inputs are true. So neither of them or nor of them is a NOR gate. And this last one, only when both inputs are true is the output true. Well, that's an AND gate. Okay, let's have a look at the question, or the two questions. State which is truth table for a NOT gate. Well, that's going to be B. And for a NAND gate, it's going to be C. Okay, so that's all you need to do for that. You don't need to label these up. We will just have a look through to make it useful. Okay, I'll record another video for the next question.